This procedure covers one commonly used method for removing surface mount chip components. A caution about removing glued chip components. A small dot of epoxy is often used to hold chip components in position during wave solder processing. Typically, these components will be located on the bottom side of a circuit board that has through-hole components located on the other side. Whenever you see a board like this, you can generally assume that the chip components will be glued onto the board. You'll need to leave the tip on the component for 1 or 2 additional seconds in order to transfer enough heat to overcure or soften the adhesive. If required, take a wooden stick or curved tweezers and push the components sideways until the glue joint finally gives way. The minimum skill level needed to complete this procedure reliably is intermediate. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. Tip preparation. Fork tips are designed to fit over the top of chip components and to reflow both solder joints at once. The ends of the fork tip fit over the component with just a slight amount of extra space for solder. Measure the overall length and width of the component with a caliper to select the proper size tip. Check the tip for proper fit prior to processing the part. The tip should not fit the component so tightly that it will get lodged in the tip, but the tip should not be so loose that it will not conduct heat to the leads simultaneously. The size and shape of the fork tip will have an effect on the rate of heat transfer. Larger tips with more surface area will transfer heat faster than smaller tips. Fork tips can be used to remove a number of different styles of chip components, but the component must fit properly in the tool cavity. Since fork tips have a cavity, they require special cleaning and tinning procedures. Tip preparation. Step 1. Remove any solder from inside the tip cavity with a fiber tool. Caution: do not use a wire brush for any tip cleaning procedure. A wire brush can severely scratch a metal tip. Scratches allow oxidation to form on the base metal of the tip, and this will severely decrease the useful life. Step 2. Remove any oxidized solder by shocking the tip on a wet sponge. Step 3. Add solder to the properly prepared tip. Fill the cavity until there is a fillet on each side of the tip. Add enough solder to help transfer the heat quickly, but not so much that it will fall out when the tip is turned upside down. The solder provides surface tension to lift the component off the pads after reflow. Since the tip has more metal surface area than the pads on the circuit board, the solder will be drawn toward the metal tip, and so will the component. Note: determine the direction the part is to be swept off the circuit board surface. Densely packed circuit board assemblies often leave only one direction for the rework tool to follow when sweeping the part off the surface. Rework procedure. Step 1. Apply a small amount of liquid flux to both ends of the component. Step 2. Place the fork tip directly over the top of the component. The extra solder on the tip will melt both solder joints. When the solder has melted, slide the component out and up. Once the component is removed from the circuit board, it can be removed from the tip by the shocking sponge or with a dull blunt instrument applying downward pressure on the component. Step 3. Clean the area